Okay, our last video for this course is on volume. And I don't know if we may end up having to do 2 videos with this because it's a little bit longer. So we're going to look at volume. And just like in your surface area, there are formulas for this. So if you know the formula, if you can identify the shape, then you can identify the formula that matches that shape, and you'll be able to figure out the volume. And remember, the volume is how much can you put inside. And so we calculate volume as though they were little cubes that you stuck inside the boxes, okay? Or inside the pyramids, or inside the cylinders. And that's how we figure volume. It's by cubic units, whatever the unit is. Cubic feet, cubic inches, cubic centimeters, just depends upon what it is. Okay, there's some very basic things to understand about this. Your base formula for these is the area of the base. Okay, so the first thing you're going to want to do is identify the base of the 3D shape you have. If it's a cylinder, what is your base? Your base is the circle. The circle is what is the base of this, okay? If it is a pyramid, in this case it's the triangle on the bottom. If it's the cube, it's my square on the bottom. If it's my rectangular prism, it's my rectangle on the bottom, whatever I decide the bottom is. That becomes my base. And the base is always going to use whatever formula it is. If I have a rectangular base, my rectangular base is going to be length times width. If I have a circle, it's going to be pi r squared. If I have a square, the area of a square is side times side. If I have a triangle, the area of my triangle is 1/2 base times height. And that's the base, not the whole shape, but just the base. So you identify what it is. We could have a trapezoid, although I don't have any trapezoids in here, but that would be 1/2 b1 plus b2 times my height. So whatever my equation is that gives me the area of my base, that is the base of that particular pyramid or prism. And then what happens to that? It is the area of the base times the height of the object, okay, of the prism. Okay, here's my base. From here to here's my height. Here's my base. From here to here is my height. Here's my base. From the middle of this to the point is my height. So you can see it makes a difference as to what they are. So all these measurements of a cube would be, if we start with a cube, that one's the easiest. So a cube. Remember, in a cube, length, width, and height are exactly the same. So length equals width equals height. If I let each one of these be represented by the number, by the letter x, this becomes x times x times x, because my cube is length times width times height. Or I usually take the dots out and just put length times width times height, which is the side, or x cubed. Okay? So that's the easiest one of all to figure out. So what if I looked at the volume of a prism? Any prism. The volume of a prism is the area of the base times whatever the height of my prism is. Okay? So let's look at a prism. In this case, it's going to be a rectangular prism. And this rectangular prism has a base that is equal to 6 times 8, which would be a 48 square units. The height of my prism is equal to 10 units. So the volume of my prism is equal to 48 times 10. In other words, the area of my base times my height, which is 480 units cubed. Okay? Now, let's look at a cylinder. In my cylinder, I have a radius of 10. And I have a height of 25 feet. Okay? So now, what is going to be the area of my base? The area of the base is going to be the area of that circle, which is pi r squared, which is pi times 10 squared, which is going to be 3.14 times 100. So my base is going to be 314 square feet. That's how much is in one base. But what's going to happen here? I now have to have 2 times that. No, we're not doing surface area. So now I'm going to look at the area of my base times the height of my cylinder. So area, my volume now, is equal to the area of my base times my height of my cylinder, which is 25, and that's going to equal 7,850 feet cubed. Okay? Now, we've learned how to do the volume of these two things. But what about pyramids and cones? Well, a rectangular prism will make a pyramid. And I don't actually have one of those here as an example. My closest is my square pyramid. Okay? That's a pyramid. So what are we going to find out about a pyramid? Pyramids and cones are based upon their equivalent prism and cylinder. Okay? Have volumes related to corresponding prisms and cylinders. So, let's look at this first one. If this one was a rectangular pyramid instead of a rectangular prism, what's going to happen? Well, a rectangular pyramid is 1/3 of the rectangular prism, is its volume. Okay, so we know the volume of a rectangular prism that is the same. We're doing the same measurements, 6 by 8 for the base and a height of 10. So it's the exact same thing as what we did over there with our prism. But it's going to be 1/3 that amount. So this is 1/3 of 480 cubic centimeters. So this is going to be 160 cubic centimeters. Because if I actually had this in plastic and I could dip it out, I could take a rectangular pyramid that matched my rectangular prism, and it would take 3 scoops of the rectangular prism pyramid to fill up the equivalent prism. And so that's the beauty of these things. They're really related to each other. Now let's look at our cylinder compared to the cone. the cone also is 1/3 of the cylinder, which is its same size, okay? So we're going to use the same radius and the same height. So it's the equivalent cylinder, only now it's going to be a cone. So obviously it's not going to be as big as much because a cylinder would be straight up and another circle on top. So what we have to do is it's 1/3 of that. And again, if I had the plastic containers, which are at school in Jerry's office, I could actually show you that it takes 3 scoops of the cone to fill up that equivalent cylinder, which I think is really cool that you can see that. So again, my cone will be 1/3 of my volume of my cylinder, which in this case was 7,850 cubic feet. So this is going to equal 1/3 of that is 2,616.67 feet cubed. Now, we could do this way. Why? Because we had already calculated both of the volumes of the prism and the cylinder. But what if we didn't have that? What if we had not already calculated it? Well, then we can fall back on the formulas. And the formulas for this is what? For the volume of a rectangular prism, it's going to be 1/3 times length times width times height. Not too hard, is it? Your base is length times width times the height. Okay, now the volume of the cone is going to be 1/3 times pi r squared, whoops, didn't write r, I wrote 2, r squared times the height. So those are my formulas. So if I didn't know that, I could then take this one. It would be 1/3 times 6 times 8 times 10. And that would give me my answer. Do you see that? Okay, my other one, that's my volume of my rectangular. My volume of my cone would be 1/2 times 3.14 times 10 squared times 25. And so it doesn't matter whether I calculate my volume first in my cylinder and then take 1/3, or if I start from scratch to do it. So that is your volumes. So now, let's look at the volume of a sphere. Just like in the surface area of the sphere, these are formulas that you just really kind of have to learn. Okay? So the volume of a sphere. The volume of a sphere is 4 pi r cubed over 3. Or you could write it as 4/3 pi r cubed. It doesn't matter which way you write it. Okay, so now we had, oh, I erased it, shoot. Oh, I've got the information right there. Okay, what if I put half of a sphere on top of my cylinder? Remember, I had a cylinder, and my cylinder had a volume of 7,850 cubic feet. How much more cubic feet will be in there if we build a silo and put a half a sphere on top of it? Okay, so my radius of my cylinder was 10. So the R of my cylinder was 10 feet. So now that tells me that the R of my sphere is also going to be 10 feet because it has to be the same as your cylinder. So now, what is it going to be if I put a sphere on it? Well, you're going to have the volume of a full sphere and that is going to equal 4 times pi times 10 squared divided by 3. And that is now going to equal 4,186.67. And let's cube not squared. And that's going to then be cubic feet. Now I've got to divide that in half. Why? Because I only want half of that sphere. And so half of my sphere is going to be 2,093.33. 2,093.33 cubic feet for half of my sphere. Now we're going to add those two together. So you're going to have your cylinder plus your sphere, and that is going to give me my silo. Okay, so I've got my silo, and my silo is going to have 9,943.33 cubic feet of grain can go in that silo. So we can use this to figure out a lot of really cool stuff. And you can do things complex, or you can do things pretty simplistic. And it opens up the door for a lot of calculations on this. And actually a lot of fun applying this to real life situations. That's the beauty of geometry, guys. There's so much in geometry that applies to life. And that's the fun part of it, because you can use it. You can use it to do stuff. So anyway, here it is, volumes of prisms, volumes of cones, volumes of pyramids, volumes of spheres, and it's all here. And this is your last lesson, and now you're getting ready for the end of the course. So you've been great and awesome, and just keep on working hard. You're doing great.